Welcome everyone to our class on binomial distribution. Today we are discussing binomial distribution, a statistic tool that is critical for predicting outcomes in business scenarios like customer conversion, quality control, and risk assessment. So by the end of this class, you'll be able to define the binomial distribution and its parameters. You'll be able to calculate probabilities using Excel, then visualize results and interpret them for business decisions. Now, let's look at the core principles of binomial distributions. So the question is, what makes a problem a binomial problem? Okay. Now, there are four non-negotiable conditions for a problem to be judged a binomial or to be seen as a binomial problem. The first is that there must be fixed trials, N. The second non-negotiable condition is that we have a binary outcome. That is, each trial can either be a success or a failure. Judging from my example, sales will be success, right? Failure will be no sales. So we only have two outcomes, success or failure. The third is a constant probability. That is, the chance of success remains unchanged. The fourth non-negotiable is independence. That is, one trial doesn't influence another. Let's break down this binomial formula we have before us here. If you look at this binomial formula, I have simplified it to make sure we don't have any confusion. So now, if you look at our formula, we have the combination term. And the combination term here counts ways to achieve X success in N trials. So this combination term can also be called the binomial coefficient. And the binomial coefficient is what we write here, or what we represent here, as N factorial divided by factorial of X multiplied by the factorial of N minus X. Then we have our probability term. Our probability term is the chance of success, right? So we have the failure term. The failure term here is 1 minus p to the power of number of trials, that is N trial, the number of trials, minus the chance of success, which is X. We are going to see how we can calculate this manually and then how to use Microsoft Excel to simplify the process, okay? So let's look at the question that we have to calculate manually. The probability here is 30%, right? Our question says with a 30% open rate. So that is our probability. And this probability is presented in proportion. So we have to always remember that we take out the percentage sign. And how we do that, you can simply just divide your 30% by 100, right? And you definitely get 0.3. So our probability is 0.3. The number of success is 3, as you can see from the question. From the B part of the question that reads, what is the probability that exactly 3 persons open it? Okay, so our X now is equals 3. So if we put this within our formula, we'll be able to perform our calculation. We can calculate this manually and then head on to using the binomial distribution function in Microsoft Excel to calculate it. So in Excel, we can calculate factorial with fact, right? So factorial of 10. And if we impute 10, we hit enter, we will have the same value. That is a factorial of 10. You see this sign here after N, that sign, that exclamation sign. Pardon?
Yeah, N factorial. That N factorial.
Yes, that is N factorial. And from our question here, you can see that our N is 10, right? So, and we are looking for the factorial of 10, okay? So let us now do the factorial of X now. So factorial of X will be equals to fact open our parentheses, and our x is 3, right? Close our parentheses and hit enter. So this will give us the factorial of 3, okay, and which is our x. The factorial of n minus x directs that we must do n minus x before we do the factorial. So n is 10, x is 3, that makes 7, right? So it will be the factorial of 7 because 10 minus 3 is 7. All right, so say equals fact. So we now have the factorial of n minus x. We can now bring these values into this section of our formula so that we actually get this, okay? So if you do this now, multiply x factorial by n minus x factorial, okay? We can basically just say x factorial multiplied by, just for label's sake, multiplied by n minus x factorial. So we are just using this as a label, okay? So now we want to do this multiplication, and that will be equals, our x factorial is 6. Let's multiply that x factorial by the factorial of n minus x, which is this. We hit enter. So we have our x factorial multiplied by n minus x factorial. So we can create another label to say n factorial divided by x factorial multiplied by n minus x factorial. Okay, so this is our label that looks exactly like this section, which is our combination terms. Okay, so here our formula will now be equals n factorial is what? This is the value of our n factorial divided by the multiplication of x factorial by n minus x factorial, which is this. So we hit enter, we have our answer for this section as 120. All right. So our combination term here, this section here, that counts ways to achieve x success in n trials will be equals to, say, 120. Okay. So I've basically gotten that combination term. So now we know that our probability here is 0.3. So we are doing the probability of 0.3 to the power of x, isn't it? Okay, our probability to the power of x, which is our number of success. Okay, I just want to copy this here. So, okay. So what we'll do now, we'll say equals, our probability is 0.3, right? And we can enter to the power from insert. Okay, we can just insert this. Okay, and x is 3, right? So basically, this serves as p to the power of x. We hit enter. So our p to the power of x is 0.027. So let's calculate this now. So say equals 1 minus our probability, which is 0.3, will definitely be 0.7, right? So say equals 0.7, then to the power of n minus x. N is 10, x is 3, right? So n minus x will be 7. Okay, so let's insert to the power of n minus x, which is 7. Okay, so we'll say 7. We hit enter. We have our value. So we can basically now just go ahead and fix this up, because this multiplied by this multiplied by this, that is what gives us our binomial distribution. So let's look at our binomial distribution now. We've successfully calculated our combination terms, which is 120. We successfully calculated our probability to the power of x successes, right, which is 0.027. Then we calculated our failure term, which is this part of the binomial formula. So let's just enter the our binomial distribution now. So we'll say our binomial distribution, right? Our binomial distribution now will be equals, okay, equals, we have our combination term 120 multiplied by our probability to the power of X successes here multiplied by our failure term, right? So this will now give us binomial distribution. Let's use the binomial distribution function in Excel to see if we are going to get the same value, okay? We'll say equals binom.distribution. So this is the function for binomial distribution in Microsoft Excel. The numbers represent the chance of success, okay? And in this case, the number is X, is 3, which is X. Then, comma, our trials, which is N, is 10. Then our probability is 0.3, right? Then, comma, then our cumulative, we have to select false because we want to return the probability mass function, okay? So you can see it side by side. We have exactly the same figure when calculating manually and as we calculated using the Excel formula. We want to visualize our binomial probability. We have our successes ranging from 0 to 10. The number of trials is 10, and the probability is 0.3 in this example we want to look at. So let's call this cell probability, okay? This will be our probability of success, okay? So what we'll do now is to enter our formula here. We'll say equals Binom.DIST, okay? Open parentheses. So X comes first, which is 0, right? And 0 is in A2, comma. The number of trials is 10. We have trials here, 10, right? Then, comma. Then, probability is this, 0.3, right? So click on it, comma. Because we want the probability of exactly X successes. So we are going to use false as a cumulative here, okay? We use false as the cumulative. So let's go ahead and hit enter. Okay, so this is the probability of 0 successes. All right. So, but we cannot autofill this because if we do, we will have a moving trial and probability, which wouldn't be correct. So let us make this cell constant. So our trial cell is in F1, right? So let's click there, F1, and then say F4 on our keyboard to insert the $ before the F column and the $ before the first row. Let's do the same for F2. So right now, we can easily autofill because we have successfully fixed these two cells. So there is something I want to show us. Take a look at this X3 success. Take a look at it. Okay, then go back to what we calculated and see. Is there a similarity? What we calculated earlier was 0.26683. When you come to success, it's 3 from our new calculations because we use the same number of trials we used earlier. We use the same probability we used earlier. So all that being constant, we will get the same value here. So we can easily visualize this now, okay? That is the number of success and exact probability, okay? So this is our exact probability. So let's visualize this now. We'll visualize by highlighting it all. Let's go to insert, all charts, okay? So let's pick our clustered column charts, okay? So this is a visualization of our exact probability, okay? So we can basically adjust the size between these columns so that it can actually looks well clustered, okay? Let's right click and say format data series. Then we want to reduce the gap width, okay? If you reduce the gap width to 0, you are going to have kind of a full cluster to show you your probability.